What? So, what about this guy here? So write the simplified standard form equation of the circle with center at 715 and radius 16. So all you got to do here, this is a piece of cake, right? This is just, it's on the board up there. This is where we're just going to write down the standard form equation of a circle and plug in the specific information for this circle, right? So the standard form equation for a circle yeah, it's just x minus h squared plus y minus k squared equals r squared, right? Where h and k are the coordinates of the center, good, and r is the radius. So then all we have to do, this is a piece of cake. I'm just plugging in 7 for h, 15 for k, and 16 for r. That's it, right? So what do I get? I get the quantity x minus 7 squared plus the quantity y minus 15 squared equals 256. If I square 16, right? That's it. That's what would go into Moodle, right there. Okay? Next one. Same kind of question. Exactly. Only this time, what's h? 0. So then if I write x minus h squared, that's just going to be x squared, isn't it? Yeah. Plus the quantity y minus -4 would be y plus 4 squared equals 7 squared, which is 49. That's it. Okay, questions on that? Okay.
Wait.
Yeah.
If you put parentheses between the x and the square, would that be okay?
It'd be fine. You wouldn't need them. It's not going to mark it wrong, but you don't need them. Okay, so what about this guy? This one's just slightly different. Slightly different. So let's start off once again with the standard form. Now this time they're giving us h and k, right? Everybody agree? So here's h is 8, k is 13, but they're not giving us the radius. They're just giving us the coordinates of another point, right? So if we write this all out, then what we're just, at this point all we have is x minus 8 squared
plus
y minus 13, good, equals r squared, right? Okay. How am I going to find r? Good, good. So they give us something else here. They give us a solution. They're telling us these are the coordinates of one of the infinite number of points on this circle, but that's one that works. So that's a value of x and y that I could plug in, right? So if I plug those in, I'm going to get 15 minus 8 squared plus 10 minus 13 squared equals r squared. So what's 15 minus 8?
7.
Squared?
49.
49. What's 10 minus 3? Squared? 9. 49 and 9 is 58, so 58 is r squared, right? So if I wanted to find r, I would have to just square root that. But if I'm just trying to write this in standard form, I'm just writing down r squared anyway, right? So my answer would just be in Moodle then, would just be, I'd go back up here. I got to put the variables back in, right? Because I want to write this in, I want to write this for all of the infinite number of possible points, not just that one. So I'd get x minus 8 squared plus y minus 13 squared equals 58. That's it. Right? Okay? All right, next one. Piece of cake. By inspection, you can see the answers right now. What are the coordinates of the center?
-3, 7.
Hold on.
3 and -7.
3 and -7. There you go. Okay, there's the center. And then the radius? 7. There you go. Okay? And so Moodle wants those separated by comma. So in Moodle, I would just write the ordered pair, comma, 7. Right? That's what I would import. Okay? Okay, how about this guy? So this is a choose the graph one, right? You're going to get a bunch of options. Okay, so on this one, that's going to be a circle, isn't it? Because both the x's and the y's are being squared.
Yeah.
But I can't recognize that circle. Now, on the graphing calculator part of the test, I'll give you one like that, but you can just put it in Desmos and it'll know to graph it, right? But you can't use Desmos on this test. This is one where you have to put this into standard form. So putting this into standard form, remember that means I got to get it to look like this. Right? So I've got to get the x's in the form of a perfect square and the y's in the form of a perfect square, and then whatever's left over on the other side is going to make r squared, right? So how do I go about doing that? Well, how am I going to write out my the next line here? What am I going to do?
Like terms.
Okay, like terms. I'm going to get, or like x terms, right? So I'm going to get the x terms grouped. So I'm going to get x squared minus 6x space. So there I'm setting myself up to complete the square for the x's, right? Okay, let's get all the phones away, please. I really don't want to see any of those, so put those away. I'm going to collect the y terms, y squared plus 12y space. And then on the other side, what am I left with? That 36 I'll subtract over to the other side, right?
Yes.
Okay, now all I got to do is just a couple quick steps to complete the square there and there, right? So for the x's, Tyler, what's the number that's going to go with x there? -3, good. And that's because it's going to be half of my -6, right? Okay, Danny, what's the number, what blue number do I have to add to both sides to make that happen? What do I have to fill in the blank with to make that perfect square? 9, good. -3 squared is 9, so I'll add that to both sides. Very good. Okay, how about here? Jasmine, what's the number that's going to go with y there? 6. Half of +12 is 6, which means what do I have to fill in the blank on both sides with then? Casey, what number is going to go there? 36, and right there. Good. And so then, what are we left with? On the other side, we got the 36's cancel, and I just get a 9. Perfect. Okay, so now I've got this in standard form, right? So what are the coordinates of the vertex then?
3 and -6.
Good. Okay, so the vertex is going to be at, or not the vertex, the center, right? We're dealing with a circle. So the center
is 3, -6.
is 3, -6, and the radius is
3.
3. So that's all we're looking for, right? We just got to find that circle. Center at 3, -6, radius 3. Okay. What number was that, 5?
We're allowed to use our notes in the test.
What's that?
We
Can't
are
you also
notes.
use your notes?
On test.
I'll let you
Yeah, on the
use,
board.
I'll tell you, I've got everything you need up on the board.
Yeah, that's true.
There's everything up there you need. Okay, so then let's find this. So we said center was at 3, -6, right? And radius was, what was it again? 3? Okay. So 3, -6.
Not that one. Not that one. Not that one. Not that one either.
That one.
There we go.
Oh, right there.
That one.
Over 3, down 6. That's it, isn't it? Because there's my center at 3, -6, and the radius is 3. So that's it right there. Okay. Very good. Okay. Okay, so now we're supposed to write the simplified standard form equation of the parabola with a vertex at 7, -8 and focus at 5, -8. So this is a little different question. You haven't seen one exactly like this, but it's pretty easy, and I thought this would be a good one to do. So all we got to do here is just graph those 2 points, right, on the xy plane. You don't even really need the x and y axes, but I'll put them on here just so we can kind of orient ourselves a little bit. So if the vertex is over 7 and down 8, so that's going to be over 7 and down 8, something like right there, call that the vertex. The focus is over 5 and down 8, so something like right there. Everybody agree?
Yes.
Okay. So describe this parabola then. Gage, what's this parabola going to do? How is it going to open up? Starts. Which point does it go through, the focus or the vertex? Well, which one is on the parabola, I should say?
Vertex.
Vertex, right. The vertex is the point of the parabola, right? And it always swallows the focus. So it's going to go like this, right? Everybody agree?
Yes.
Okay. And so then, what is the value of P? P starts at the vertex and goes to the focus, right?
It's 2. Negative 2.
So it's -2. Good. P is -2. And there's H and K, right?
Yeah.
So all we got to do is plug that stuff into the horizontal standard form equation for a parabola, right? So the horizontal standard form equation is going to have the y's squared.
Y minus
Good. So y minus k squared
4p.
equals 4p x minus h, right? Plug that stuff in and we're done. So k is -8, right? So this one's going to become y minus -8 is y plus 8 squared equals 4 times -2 is -8
Yeah.
times x minus 7, because that's h, right?
Yeah.
That's what I put in Moodle. Okay, good? Good? Okay. Okay, another one similar to that. This time I gave you the coordinates of the focus and the directrix. Didn't give you the vertex. You got to find the vertex, right? So this is the kind where we got to maybe graph that directrix line, plot the focus, and then put the vertex in the middle. So Maisie, is that going to be a horizontal or a vertical directrix?
Wait, no.
Horizontal, because it would cut the y-axis if we extended it, right? So it's going to be horizontal. Y equals -2. Is the focus above or below? Below, because the y value is -6, right? So here's the focus with coordinates 0, -6. Okay, so then the vertex. Vertex goes in the middle. Ariel, what's going to be, which coordinate, they line up vertically, right? So which one of those two coordinates is going to be the same in the vertex?
You expect for a second?
I do. There you go. Stuff that in there. Nice, make sure. All right. Okay, so which one's going to be the same then? If they line up vertically, are they going to be over the same x or up the same y?
Same Y.
Wait, no, same X.
Same x, right? They'd have to have the same x values because they're going to be both. If I started from the origin to get there, I would walk over horizontally the same amount, which was none in this case, right? These would actually both be on the y-axis. Now, what we got to find, does that make sense?
Yeah.
Okay, so then what we need to find is what goes there, right? So we've got to average those two values. It's got to be halfway between the y values of the directrix and the focus, because the vertex is in the middle, right? So what's the average of -2 and -6? -4. If I add them up, I get -8 divided by 2 is -4, right?
Y 2 though?
Say it again.
Isn't Y?
Oh, it isn't. I'm sorry.
Okay, I was really confused.
Sorry, no, that's my bad. So that should have been a +2. Whoops.
Yeah, see, I
Okay.
wanted the first time.
Sorry. So that changes things a little bit. So now,
It's just 2.
so it becomes 2. Yeah, 2 is now going to be this guy, right? The average of 2 and -6. No, it's -2, isn't it?
Yeah, it's
Negative 2. 2 plus negative 6 is negative 4. Divided by 2 is negative 2. And that makes sense because negative 2 is 4 away from negative 6 and 4 away from positive 2, right?
Yeah.
Okay, so then P goes, so our parabola opens up or down? Down, because it's got to swallow the focus. And remember that, just another little thing, remember that the parabola is always going to be kind of perpendicular to the directrix, isn't it? If the directrix is horizontal, the parabola is vertical, and vice versa, right? Okay, so what's the value of P then? Negative 4, right? Because it's starting at V and it's going down 4. So P is negative 4. We know that H and K are the coordinates of the vertex, so that's H and that's K. And so if we're going to write the standard form equation, then we're just going to plug in H and K and P, right? So we're going to get X minus what? H, which is 0,
Yeah.
right? So X minus 0 squared, which we could just write as X squared, right? Equals 4 times negative 4 would be negative 16, right? 4P. P is negative 4, and I gotta multiply 4 times P, right? So negative 16 Y minus negative 6 plus 6. So that's my answer, correct? Everybody agree? Okay. Questions on that? Okay. Okay, choose the graph of the parabola and focus corresponding to the equation below. Okay, so this is easy, right? They're giving us this in standard form, so we can look right on there and see what H and K and P are, right? So what's H?
Negative 6.
Yeah, in fact, I'm just going to go... right there, okay? So let's just summarize this information then. Yeah, so we know that H equals what?
2?
No, it's 6.
H is 6.
What's this telling us?
Oh, wait, no, it's negative 2.
Negative 2, right? Because remember, H is always what's subtracted from X. So this part right here is telling us H is negative 2. What's this telling us?
6.
K equals 6. And what's that telling us? Yeah, P equals negative 2, right? Negative 8 divided by 4 would give us P. And so then, if Y is the variable that's being squared, is this horizontal or vertical? Horizontal. P is negative, so that means it must be opening up in the negative horizontal direction, right? So to the left. So that's everything we need to find right there. That's the summary. Okay, so let's find it. Negative 2, 6.
Nope. No. Nope. Yes. Nope.
Oh, that looks pretty good, doesn't it?
That is the one.
Okay, so then here we've got negative 2, 6. There's the vertex. And then P is negative 2, so that's it. Okay, what about this guy?
Are you assuming?
Okay, what about that? What about that? So now we got to find Y is the variable that's being squared, X is not. So this is parabola, right? We got to put this into the horizontal standard form, right? Okay, so Manuel, what are we going to do with this? I got to get this into the horizontal standard form. So what is that, Manuel? That's Y, what?
Minus. 6.
Okay, Well, okay, you don't have to be that, you're going way ahead here. So, just, what is it in general? Y minus k, just tell me the y minus k squared equals what? For a parabola, 4p, right? Times x minus h. Okay? Okay? See where we're getting at? Okay? Yeah.
No.
No. Only the y is squared with the, notice, okay, good question.
Squared would be a circle.
Exactly. Yeah, notice that when we're dealing with a circle, both the x and the y parts are being squared. But for a parabola, only one is being squared. If it's a vertical parabola, the x part is being squared, but not the y. If it's horizontal, the y minus k is squared, but not the x minus h. Right? Okay, so let's see here then. Okay, so I've got to get it to look like that, correct? So that means I'm going to have to complete the square for which of the two variables? For y. Good. All right, so let's collect. So, Ellie, let's collect the y terms on one side, right? So that's going to give us y squared plus 16y space. Everything else we want to push to the other side. So the 12x will subtract to the other side, and we'll add the 20 to the other side, right? Does that make sense? Okay, so then for the y's, what's the number that's going to go with y in that perfect square? 8. Very good. Half of 16 is 8, which means what number do I have to add to both sides?
64.
64. Good. Okay, so then that gives us, on the other side, we're just going to get negative 12x plus 20 plus 64 is plus 84.
Yep.
Yeah.
Okay, so here's the part that we got to talk about a little bit. But this is the part where I think people have the most trouble. Which really, it's algebraically, I'd say it's the easiest part, but I don't think you did a lot of this in Algebra 1. It's maybe y, but that's all right. We're doing it now. So I've got to get this to look like this over here, don't I? Right? So that means on the right side, I need this to look like something times x minus h, right? Okay, what goes out front? Negative 12, exactly. Whatever is being multiplied by x has to go out front because the x has to be by itself in the quantity, right? So I'm going to undistribute the whole negative 12. So then we just got to figure out what are we left with here. Negative 12 times x gives me my negative 12x. Negative 12 times
7.
what gives me positive 84?
Negative
Negative 7. Very good. Okay, everybody see that? Okay, so then here's my answer. Y plus 8 squared equals negative 12 times x minus 7. So Manuel, back to you. So then what's the value of h? 7. Now you said 7, right? Yeah. So h is 7. What's k? Yes, did I make a mistake?
I have a question.
Okay.
When did you subtract 64?
Oh, yeah, I would.
Okay.
You're right. Oh,
We're all
no,
being
no, no, no,
bamboozled.
sorry, my mistake. No, we don't. No, we don't. We don't. Because, sorry, it's a good question,
Okay.
but I'm adding it because I have to, remember what I have to do is I started off with nothing there. So I have to add the same thing to both sides of my equation.
Right. Okay.
Right. 8 squared is 64, so I've got to add 64 to both sides. Does that make sense? Okay.
What?
Wait. So it
Two
is.
whales need
So it
answers.
is at 64?
It is, absolutely, yeah.
But you have to add it on both sides.
You have to add it on both sides. So let me go back here for a second. I'm just going to undo one step and redo it. Okay, here's where we are, guys. Let's go back a second. Everybody with me? Okay, so in the process of completing the square, we know that we're going to get the perfect square for the y plus 8 squared, because that's totally based on the first two terms. That's based on y squared plus 16y, right? But in order to make that happen, I have to start with the perfect square trinomial, y squared plus 16y plus 8 squared, right? So that means I have to go back, and because I have an equation, I have to add the same thing to both sides. I have to add half of 8 squared, or 64, to both sides. Because now, those three terms, y squared plus 16y plus 64, factor into y plus 8 squared. Think of magic numbers. What two magic numbers multiply to 64 and add to 16? 8 and 8, right? In other words, we've got y plus 8 times y plus 8, or y plus 8 squared, right? Okay, on the other side, then that gave us this 84, okay? So h was 7. Manuel, what's k? Going back to this line right here. Look, compare this to our standard form. What's k? What's being subtracted from y? It's negative 8, right? Because that's positive, that means k has to be the opposite of that, right? So k is negative 8. And what is, Caitlin, what's p? If h is negative 12, what's p going to be? Negative 3, very good. We're going to divide that by 4. Okay, so p is negative 3. And then this is going to be a horizontal parabola, right? And if p is negative, what direction are we opening? Left, very good. So we know that it's going to look like that. Okay? Okay, so let's find that one. Okay, notice on this one, they don't give us the focus for each graph. So all we need to know is which way it opens and do we get the right vertex. So 7, negative 8. About right there. Over 7, let's try this one. Over 7, down 8, opens to the left. That's it, isn't it?
Yep.
Right? Okay, got it? Okay. Okay, let's look at these. All right, so these are the, now we're moving on to the part where we're just going to solve some systems, right? So we're going to solve these linear systems, right? Okay, so let's see here. So which technique am I probably going to use to solve this one? Substitution, very good. So Brandon, what would you multiply something by here? What are you thinking? We got to either get the x's to cancel or the y's to cancel. We would like to multiply just one equation if possible, right?
4x by 3.
Okay, yeah, if I multiply the top equation by 3, that would give me a 12. I'd end up with a 12x on the top and a minus 12x on the bottom.
Yes.
So those would get eliminated. That's good. Okay, so let's do that. So top one, multiply by 3. And if I multiply, Brandon, what do I get if I distribute a 3 all the way through both sides? I get 12x,
15.
good, minus 15y equals 24, good. And then the bottom one we just leave alone. Negative 12x plus 2y equals negative 24. Okay, so when I add these up then, look what happens. When I add these up, the x's cancel, right? Okay, so then what happens here? I get negative 15y plus 2y.
Negative
13y.
Negative 13y. Ah. Okay, so if negative 13y equals 0, what's y? 0. Yeah, it's 0, right? A couple ways you can look at this. We could either say, okay, what would I have to multiply 13 by to get 0 would be 0, or if I want to just divide each side through by negative 13, doesn't matter. 0 divided by anything is 0. So y is 0. Where would I go to, Ashley, where would I go to find the corresponding x value?
Origin.
Okay, the origin. So I found, so I found the half of my solution. I found the y part, right? To find the x part, I'm just going to go back to one of the original equations, doesn't matter which one, and plug that y value in and solve for x, right? If I had had a substitution equation, I would have gone right back to that, but I didn't have one this time, right? So probably it'd be easier to go back up to the top one, the little smaller numbers, right? So in the top one, then what would we get? We'd get 4x minus 5 times 0 equals 8, right? So yeah, 4x equals 8, so x equals 2, right? So my ordered pair is going to be what then? 2, 0. That's it. Okay, make sense? Okay, let's do another one. Okay, how about this guy? Stare at this one for a second.
Multiply by 2, that's by 2.
Okay. Everybody agree that it would make sense here to get the x's to cancel?
Yeah.
I could multiply bottom one by 2, leave the top one alone. Okay. Oops. Okay, hey, listen, I just feel like for some reason we've been so good the last few days. Today, for some reason, I just seem like there's like a lot of talking going on out here. Which, sometimes it's math stuff, but it's so easy to get distracted. Don't let yourself get distracted. I mean, I think honestly, if you can just condition yourself here for this period to just go through these problems, this is not a very hard test. You could come in tomorrow and get an A on it, honestly. But if you don't get yourself ready, when are you going to get yourself ready? When's it going to happen? Because next week is it, right? Yeah, the videos are up there. I'm putting this video up there, but are you going to do it? I don't know. That's hopefully, but get it done now. You don't have to worry about doing it at home. Just go through this and feel comfortable with it. If you can get this stuff, it's easy to re-get it later. If you can get to a point where it's like riding a bike. You learn to ride a bike, you can not ride a bike for 20 years, and you still can get on there and ride a bike pretty well. Once you get it, it's easy to re-get it. So if I multiply through by 2, I'm going to get what? Negative 10x minus 4y equals 2. Now what happens when I add these up? Everything cancels. I get 0 equals 0. How do we interpret that? It's IM. It's IM. And here's what, okay, IM stands infinitely many, right? So there's two options. When you get a weird answer like that, where the variables go away, remember, it could either be no solutions. That would be what we would interpret if we got an untrue statement that's never true. This time we got a true statement that's always true, and so the answer is IM. Okay? Yep.
Could you ever get a situation where it's like 1 equals 1 or 2 equals 2 or something like that? Or is it always 0 equals
I mean, no, it could. If you use substitution, sure, it could work
So
out
would
that
it
way.
be infinite still?
If it was true, it would still be infinite. If it was 2 equals 2, right. If it was 1 equals 2, it would be no solutions. Yeah. Okay, how about this guy?
When the graphs don't switch up when it's NF, right?
Right, if they're parallel lines. Okay, so what about this one now? This time, what strategy are we going to use? Substitution. Good. Right? So I've got this solved for y, so I'm going to plug that in for y in the top equation, and that's going to give us, the top one's going to become 2x plus 5 times, I'll just open a set of parentheses to make my substitution, equals 26. And for y, I'm going to plug in negative 5x plus 19. Good. So now all I've got to do here is just simplify and collect like terms and solve for x, right? So if I distribute the 5, what am I going to get? Justine, what do I get if I distribute the 5 through those terms? Negative 25x, and then that's going to be a big one, isn't it? What's 5 times 20?
95.
It's going to be 95, isn't it? 5 times 20 would be 100, minus 1 times 5 would be minus 5 is 95.
Yeah.
So plus 95. equals 26. Let's collect like terms. 2 minus 25x is
Negative 23.
good. Subtract 95, and I'm going to get 69, negative 69. Okay, divide both sides by negative 23, and x equals 3. Where do I go to find y? Right there. And now I won't even bother. We'll get running short on time, so I won't even do it. But I could plug that value in there to find y that goes with it, right? Okay, last two. I want to get to at least a couple of these, because these are the ones I feel like people might need the most help on. So what about this? Now here we've got a quadratic linear system, right? So what's the variable that's being squared? So I want to probably substitute for y. Good. So in that bottom equation, all I'd have to do to get y by itself is add the 5x to the right.
Yeah.
Everybody agree? So then we come up with the substitution equation, y equals 5x plus 1. And we'll plug that in right there, right? So then that equation becomes x squared equals y, which is 5x plus 1 minus 5, right? Okay, now let's focus on this. This is a quadratic equation. I've got x squareds and x's. So my goal is I've got to put this into standard form and solve the equation, right? So if I subtract the 5x to this side, 1 minus 5 just becomes negative 4, right? So I'll add 4 to this side. Everybody agree that's what I get? X squared minus 5x plus 4 equals 0? Okay, how do I solve this? Could use quadratic formula, could complete the square. I want to probably try to find magic numbers. Do they exist?
Nope.
Numbers that multiply to positive 4 and add to negative 5.
Oh, actually.
They do, don't they?
-4, -1.
And negative 1, yeah. Okay, so those are my magic numbers. So then that means what are my solutions going to be? I'm going to use the zero product property. So the product equals 0 when the factors are 0. So what value of x makes that one 0? 4.
And 1.
Good, and that one would be 1. Where would I go to find the y values? Right? So if I plug in x equals 4, 5 times 4 is 20 plus 1, y is 21. If I plug in 1, 5 times 1 is 5, plus 1 is 6. So my solutions would just be the ordered pairs, 4, 21, comma, and then the other ordered pair would be 1, 6. Right?
Yeah.
We good? Kenzie?
Can you explain where you got the y values again? You
Uh,
just put it in?
Yeah, I plugged it right back in there,
Okay.
right? My substitution equation.
How do you know y equals 5x?
5x plus 1, all I did is I took this equation and I just added 5x to both sides. Okay, make sense? Okay? We good? All right.